Okay, so today in class we talked about situation and solution equations for addition and subtraction, and tonight we're just going to extend that to include multiplication and division. So this is 6-2 situation and solution equations for multiplication and division. So some quick vocabulary that I want you to write down. It's important. It seems like a lot, but it's the only vocabulary that we'll have for a while, so I want you to make sure you write it down. Is the definition for a situation equation. Remember that a situation equation is the equation that shows the action or relationship within the word problem. So literally, it's exactly what the word problem is saying. So as an example, we might have Liam has some change in his pocket. He spends 25 cents and now he has 36 cents in his pocket. So how much did he have to start with? So when I think about the action in that problem, I have that he has some change and then he spends it. So when I think about that action of spending, I think, well, I started with some money and now I have less money. So less money means I'm going to be subtracting. So when I look at my situation equation, you can see that he has, let me see if I can move this over. He has some money, an unspecified amount. He spends 25 cents and he's left with 36. So this equation shows exactly what happens in the problem. Now, alternatively, there are solution equations. And solution equations are virtually the opposite. It's where you have an equation that shows the operation that you need to solve the problem, not necessarily what's actually happening. So if I still have Liam here, my friend Liam, who had some money, and he spent 25 cents. So remember, he had some money, he spent 25 cents, and now he has 36. To solve that problem, to figure out how much money he started with, then I need to rearrange the problem so that I'm going to equal that amount. And in order to do that, we know that we would add. So that would be x equals 36 plus 25, because I know that if I put these two parts together, then I will have my total. So if you think to kind of like a math mountain, where he had some money, spent 25, still had 36. If I put those together, I would find that whole. Okay, so that's a review of what we did today with some specific vocabulary. I want you to make sure that you write down the definitions for both a solution equation and a situation equation, and the example, and both the situation and the solution equations. Okay, so I guess what I'm saying there is you don't have to write the example 2 times because it's the same example on both slides. So write down this definition, then write down this definition, then write the example, and then write both of the equations. Okay, hope that wasn't confusing. So here's another example, and this one is multiplication or division. So we have a school gymnasium, and 375 students have gathered there for an assembly. The students, oh, that's a typo. The students, forget that beat. The students are seated in 15 equal rows. How many students are seated in each row? So just like with addition and subtraction, we kind of could use that math mountain idea. What we're going to do with multiplication and division problems is we're going to use a rectangle. So knowing that the rectangle almost represents that area model, okay? So if I have 375 students gathered for the assembly, they're seated in 15 equal rows, how many are in each row? When I look at this rectangle and I think back to what I know about an area model, I know that this is kind of the product and its factors are on the sides. I would like you to draw that. Okay, so we know that factor times factor equals product, right? Go ahead, pause and draw that now. It's been so long since I've done a video. There you go. So now I'm going to use that same rectangle and I'm going to use it for the information I have. So we have a total of 375 students sitting in the gymnasium. So I'm going to put that in here, 375. And they are sitting in 15 equal rows. And I want to know how many are in each row. So I'm going to give this, I'm going to say S for students. Okay. So now if I want to write my situation equation, remember, I'm writing the operation that is the action within the problem. And when I do that, I'm going to have 15 times S for students equals 375. But that's not how I would solve it. If I wanted to solve it, I would have the solution equation. That is 375 divided by 15 equals S. Remember, with our solution equation, our variable or the unknown should be on its own side of the equation. Okay? So, I'm going to give you an equation. Actually, I'm not going to give you an equation. I'm going to give you a rectangle. And with this rectangle, what I would like for you to do is write for me the situation and the solution just based on the rectangle, if you can. So I'll make it really simple for you. Okay? Refer back to this one to help you. See you tomorrow.